does water react with water?
Just like it did when we were doing acid base. Do you know bang on a door?
Who's that?
Hello? Which one of these is a volumetric flask?
That one. No,
Okay, you were both wrong. I don't know how you could have done that.
Which one did they choose?
One on either side. Okay.
Google a
I
riddle.
didn't watch Breaking Bad.
Oh, no.
That
Okay.
explains what a volumetric flask is.
H2O splits into H plus OH minus. The bottom reaction should give exactly the same products. Which one of these is an Erlenmeyer flask?
That one.
Neither. Okay, you only you.
How did they get that wrong?
What's
That's
a
like
riddle?
a basic.
Pardon?
What's a riddle instead of people pointing at things?
There are 30 cows in the field.
You're
I don't know any other ones.
Okay. Two girls are born on the same day of the same month of the same year, but same mother. They are not twins. Why?
Two girls are born on the same day, the same month, the same year.
The same mother. They are not twins.
Because the wait, no.
They have a brother. They're triplets. Go tell them.
Oh, they're not twins. They're
Yeah.
Oh,
Two girls are born on the same day, the same month, and the same year to the same mother. They are not twins. What are they? That's true. That's true. That's fair. I felt it. My purity decided that wins.
no, a nay, just a nay.
Just a
nay.
nay.
Just a nay.
No, everyone can come in.
Oh.
I like how Lucas decided just to obey what the class said. Everybody else is go back in. Oh, Luke, sorry. I should have let you in. You actually have a reasonable excuse to be a little slower.
They have the same one, no, they're triplets.
Apparently they're triplets.
Not twins, they're triplets.
They have a brother.
Twins.
Yeah.
Brother.
This is an Erlenmeyer flask that will be important for later on today because you're not going to use it. This is a volumetric flask, and this is a flat bottom Florence flask. Florence flasks are normally completely round. This is a little unusual because it's for students, and so they don't put it down and it flips over. The reason they're normally round is because these are for heating things up, so you want as much surface area as possible. This is the one you're going to be using today. This is worth substantially more than every other piece that I've just shown you, and quite a bit substantially more than this beaker. Beakers are used because they have a relatively wide opening. You can get stuff in and out of them really quickly. But their error is not plus or minus even a mil or even 10 mils. Their error is probably plus or minus 25 mils. They're thoroughly inaccurate. They're mass produced and mass stamped, and they're kind of in the range. Whereas these have an error rate stamped on them. They only measure one volume. And you will assume it's plus or minus 0.1. But I think it's actually got stamped on it plus or minus 0.24. So you can measure out 250 mils and only have plus or minus 0.24. Now, when you're measuring, over here. Count them up. When you're measuring, you have to make sure the meniscus of the water. What is the meniscus of the water? The curve, yeah. So, when you're measuring, there will be a meniscus. You measure from the bottom of the meniscus, and the bottom of the meniscus should line up with the line, and that hairy eyebrows, nose. There we go. Your average student looking at it. You should be looking at it dead on. If you're looking at it like this, you are not getting to the bottom. If you're looking at it like that. So one of the safety standards you need in every lab is a bunch of stools and chairs so you can sit down and actually do that. We don't have that, so do that best you can. Hopefully we have that next year when we have the new building. So you'll be using this once you've made it up into this. You're going to cover the top with some parafilm, and then you're going to label it, and then this is going to become yours for next time, because it's your part of the lab is you're being marked on your accuracy. So this is your solution. You don't want to use anybody else's yucky solution. You want to use your solution. You work in pairs. When you titrate next day, you're going to also titrate a different standard with this. You're also going to keep that, label it with your name so that you have an acid and a base. The reason this one is done is because we're using an acid that's not hygroscopic. It doesn't absorb water from the air. Relatively, well, it's a little bit more expensive. And we can measure out its mass precisely. But then we're going to use that to titrate sodium hydroxide so we can know it. Because sodium hydroxide does absorb water from the air and the mass is never accurate. So you have to confirm its concentration before we then use it to titrate some more acids. So this glassware is the one you'll be using. You have to be careful that every single bit goes in here. So you'll weigh out your solid sample into a clean, dry beaker. One of the reasons it says, mass of the beaker, then mass of the beaker plus a solid, because if you tear it, yes, it's zero, but what if somebody walks by it, it moves, tears improperly. If you have the mass of the beaker, it doesn't matter if you forget or it accidentally shuts off, you know the two of them together, and you're much more safer that way in terms of a lab, or if you have to reuse the beaker. Make sure it is clean and dry. When you transfer it from here into here with a funnel. These are notorious. You fill it up, and then all of a sudden you don't realize because it's going slowly that you have more water in the air that's in there. You go past the line. Can you just pull that liquid out, and then you're fine?
With like a pipette, maybe.
You could pull it out with a pipette. How would that do for your accuracy? Not good, because now you're pulling out some of the dissolved solid, and it's now useless. You have to discard the whole thing and start over again. So you cannot go past that line. So what you'll do is you'll take your solid, dissolve it in a little bit of distilled water, and put it in, and then rinse this really well, so every single speck of solid ends up in there. Then you'll dissolve everything, make sure everything's off the funnel. Once all the solid or any bits of liquid are off the funnel, then you'll have it in here. When it gets about there, then you just swirl it until every piece of solid is dissolved.
So you're putting in the solid, like you combine the solid with like just a little bit of water so that...
Yeah, so you can get it rinsed in there. You don't want bits of like powder floating up or getting knocked off or stuck to the side. You want it all rinsed in.
So we rinse everything with water, and the water goes into the...
Yeah. And then when it's about halfway full, you get it so it's completely dissolved.
Okay.
Then you make it up a little bit more, usually mixing it because you want the solid to dissolve through. It'll change its density slightly. And then when you get close, you want to get the bottom of the meniscus dead on that line. Then you cover the top. Or actually, if you're wearing gloves and you have big fat fingers like mine, you can just cover it like this, and then you make sure it's well rinsed.
So not bad to have acid in your fingers.
Pardon?
If you have gloves.
No, it's a mild acid. It's a weak acid. Or you can just cover it with a bit of parafilm. Double check the volume. You've got all the bubbles out. It's at the same mark. And then you label it and tie it off with a bit of parafilm. Parafilm is just, parafilm. It's like wax. Take it, put your thumb there, pull it over, and you just go around. And now you have a seal. What you don't want is that water to evaporate over the next coming few days, and then to make the concentration more concentrated than you intended, because it will then drop the volume. You've done a lot of work to make sure you have an exact, precise amount of volume in there. If you allowed that to just set out open, some of that volume would leave, and now it would slowly get inaccurate over time. So that's all we're doing today. There's a lot of little skills that went into that, but it's only going to be like the last 20 minutes of class. You're going to go up there, get these pieces. This is out there. It's in a covered across the way. These are in a tray over on the side. I think we're going to be working down the physics side because it just snows. Class is doing something in there. You do want to use distilled water. because we don't want any other weak acids in there from our pipelines. We've got the oxalic acid here, weighed out with the scale. And then these are all filled with distilled water as well, so you can rinse the stuff down. The only one, and beakers are also in the cupboard over on the side. Hold it. This does say 10. Don't use this one. I didn't notice that. This says 10% bleach. That would be hugely bad.
Why did you print
Would
that?
that like cause some sort of bad reaction?
Well, yeah, actually, it would not only cause a bad reaction, it totally ruin it as an acid because it would react with the acid.
Would it like explode?
Would it cause
No, it might cause a mild amount of chlorine gas and you cough for it. It mostly would make it so your acid wouldn't work as an acid because it would have already reacted and then again you'd have to start all over again.
water.
Yeah, yeah. So use the ones, always double check labeling that they actually say
Don't just
distilled
blindly
water.
trust
Yeah.
this to be
One thing of labware is you're supposed to have different shaped bottles for different types of solutions. So this is not great practice, but on the other
Seems
hand,
like
they're
pink
cheap
cup red or
bottles.
So do you think it's actually water or bleach?
Oh, it's bleach.
It looks
Oh.
like
Because of COVID, we made up a couple of those just so we can spray things down. So that's the last little bit of class. In addition, as Rome, where are they? What I'll have is as soon as you've made that up and it's sealed off and ready to go, you'll come and see me. And I have a copy of your test. Now, I'm not giving you your actual test. You don't get that back quite yet. I have to put one in the library. But what I do have here is I have the comment I made about your practice workbook. And then what is down here is it gives you the critical analysis part of your test as a proficiency. It gives you the communications part of your test as a proficiency. It gives your overall test percentage. Then it gives you how well you did as a percentage in each section, reaction kinetics, equilibrium, or solubility. So you can look at it and go, oh, I did really well in solubility, but I absolutely need to go back and review my reaction kinetics before the final exam. Then I give you your current marks, research and experimenting, critical analysis, communicating scientifically, and then your current mark. All of this, by the way, was stuck in Mr. Wardo's program. And so I had to learn Python to pull it all out and print pages yesterday. It turns out, in case you need to do this, ChatGPT knows Python. And I just asked it what to do, and then I followed its steps. And then at one point it warned me, make sure you trust the person who's telling you this because you could wreck your computer. I'm like, I trust you, man. Got it. Below that, I have your rough report comment. So this has not been through an editor. This is what I've written, and they've now gone to editors. But then you can check for things like, I know your name. I didn't say anything that is like, Mr. Neufeld, okay, I know that that's true, but my parents will absolutely kill me if you phrase it like that, or they won't understand this. And you can read through it, make sure it's fair, make sure it is accurate. I get feedback. If you ever really want to know what I said and you don't understand the report, always ask me. Because as I told one student, he was like, what do you mean about shades of gray, and I should, add more detail? And I'm like, in science and ethics, you always pick the most extreme of the two sides, which makes all of your discussions really easy. You should pick something more mild, so that when you're in there, you can get at the details of why one side is wrong or the other. And he was like, but if I say that in there, it's kind of hard to say, your son doesn't have the emotional maturity to pick some middle grounds nicely without making it confusing. So these are written in a way that's supposed to be read by everybody, including parents and advisors, so sometimes they're a little too vague. Any questions? You can't keep this. I might not be allowed to show you your report beforehand. I'm not entirely sure.
Why not?
You won't tell. Other teachers
So, well, other teachers do, I know. So what I'm going to do is I'm going to give it to you, but then I want you to give it back, and please don't take a picture. You've seen all the information, you're about to get it. So just take it, take a look at it. When you're done with it, just give it back to me before we go. We'll do it at the end. So you'll go do the bottle, I'll have these, and then I'll give it to you, take a look, and then give it back before you head out.
Why can't we do it now?
Well, because no one will pay attention to that.
Yeah, we will.
No, you
Yeah, we
will.
will.
I know, I've done this. See, the difference is in first year I would have agreed with you.
But here's the thing. Now we're just gonna be thinking about that instead of this.
Yeah, but that's okay. I'm okay with that.
You can't talk about it. We need closure.
Closure is coming. The end of class. It's anticipation. Okay, what are the two products for H2O plus H2O given the top reaction? Not H2O. I'll give you a hint.
Oh wait, no, 2H2OH? Maybe?
No, one of them.
H2 plus.
Oh, nice one. H3O plus.
Oh, oh, bro.
These are. Do you not have one? Where did the extra ones go?
Go to that.
These are the same reaction. This is like the official reaction. That's what really occurs. And the first one is what we say occurs, because who wants to write an extra water molecule when you don't have to? So this is a shorthand. His name is Ryan. And actually occurs.
Or no, where?
What?
The notes.
Are there no more? Hold it. The printer was
Okay.
acting oddly
Because I was like, there's a cut.
in the last bit. There's none in the back. Desk. Hmm. The weird thing is, I should have like 5 extras over and above those, because like 3 people in the other class don't even use them.
I'm so sad we can't look at
They're not sitting on the desk here somewhere.
We're gonna be gone.
They're right here. No, they're not. Okay, I'll go bring them up. Because that's annoying. Sure, I wasn't all ready to go. Right. We literally have more than enough yesterday.
I swear there was like a pile in the back.
Wait, did you include the hydrate?
No,
You got it from a pile?
I didn't include that.
Maybe it was just one sitting on top of a pile of containers.
Maybe.
Okay, so I got it wrong. I told him I got it wrong. I knew I got it wrong. So I'm still trying to redo it.
Okay, let's redo water really quick.
I guess not. The weird thing is that I print exactly enough I need plus 2.
Because I thought that was just like.
And then like 5 people in the class take notes on their iPad. They don't even use them. So there should be technically a ton. How many people don't have one? Just one? Sophia?
Me and Luz
Do you have one?
2 copies.
Oh, that's not gonna work. Is our color photocopier is doing badly?
So we actually have.
Oh, while you're waiting, write the equilibrium expression for this down below. Write the K Q.
Don't think like I.
now. They'll be ready in 2 seconds. If I was to write the K for either one of those, what would I get? Dylan, what are you doing?
I got my answer wrong for the lab, so I gotta just.
Yep, put it away. Now's not the time. Now we're on here.
Dylan,
How you did it?
you didn't. You don't count water as your molar mass.
We checked.
Yeah, I didn't count the water.
No,
Wait,
that's
but
right.
you got
Okay.
it right.
Oh, I got it right! Look at me go. Wait, so let me just undo that.
Wait, do you count one?
Let me just undo that real quick.
Would it be one for
Look
water?
at me.
Or no, no.
Why did I?
You were like,
You have to lie. You're not allowed to fucking-
It would be when it's on the sheet. I don't
It
know.
was in the formula, so it
Cause in the yeah, so it's in the
Hold
formula.
on, hold
If
on.
it's in the formula, you need to account for its mass.
Yes, we did.
Right. Oh, okay, good.
Okay,
No, because
top reaction. What's its KQ? How do you calculate KQ?
Would it be
Products of reactants.
Products over reactants. What are our products?
OH minus and H2O plus.
Right, so we just put H3O plus and OH minus. That's the products. What reactants do we put it over?
Over H2O squared.
Over H2O squared. Really?
But it's a liquid, so it doesn't go in.
But it's a liquid, so it doesn't go in. Because these are all liquids. So it actually, in the end, doesn't matter which one of these reactions you use. Because it's a pure liquid, it doesn't appear in the KQ. So that actually goes away. And because this is so important, we call it a KW. It is the K expression for water. So it's a single reaction that gets its own K value.
Is H2O and OH, are those just aqueous?
Yeah, they're both just aqueous. They have to be aqueous in solution. That's as aqueous.
Chloe, so in the calculation for mass, you count the H2O as part of your molar?
I did. It's part of the equation.
We're not. Don't worry. I'll check your answer later.
Yeah, but that's
Yeah,
just,
but
like,
then
takes
I'll.
away time from the
No.
lab.
We're busy. We're doing this now.
Oh.
Yeah. Sophia, can you go to reception? It should be done printing now. Ask them for whatever came off the black and white printer, and it should be good to go. Pardon? It might be the actual mass that you're supposed to have. Okay. Predict the effect
Wait,
of.
can you go back?
Dylan, you were wrong.
I was wrong.
Yeah.
How? Oh my god. Okay, so I was wrong. Okay, so I do have to redo that. Wait, I got 1.13.
Yeah, that's
what
That's what we all got.
We didn't count H2O.
So we're all wrong?
Yes.
Shh. Focus.
Why?
Lab.
What's on the bottom that's scribbled out?
It's scribbled up because what don't you put on the bottom?
Is the reactant? I don't know, I'm thinking of K.
Yeah, this is also why I ask people not to be on the computer and focused on the class, because we've already dug on through this. How do you calculate the KQ? What over what?
Products over reactant.
Products over reactants? It's the reactant. What's the reactant?
Reactant is. Wait. H2O.
Wait. Do we include H2O?
We don't put water.
No. There you go. See?
Okay.
Done. Caught up.
Just don't include H2O.
So don't include it. So let's take out our reaction again.
Why would we do it before we learn stuff?
We've got two waters going to H3O plus and OH minus. We'll use this one. If we increase the concentration of H plus, or we increase concentration of OH minus. So if this is in fact an equilibrium, what will happen to the amount of H3O plus? If I increase H3O plus, so I make that go up, what will happen to the amount of hydroxide?
Go down.
Go down. So concentration of OH minus decrease. If I increase the amount of OH minus,
H2O decreases.
H3O plus decreases. So this is just a very long and fancy way to say Le Chatelier's principle is in play here. This is also going to rotate around a particular constant. So you're going to be able to calculate one from the other using that constant. So if you know the amount of acid, you're always going to be able to calculate the amount of base. If you know the amount of base, you're going to know the amount of acid.
There's another riddle.
Were they able to grab it for you? No? Yeah. I'll go grab them in a second. Because,
She said you can send them to her.
yeah, this is annoying. File,
Chloe,
print.
you get 1.575. Okay, that.
Do the printers here staple?
No.
No?
Yeah, printer's staple.
The printer like right out there where people, where is it? There? By the window? Does it staple? No.
How can a printer staple?
Oh my god. Okay, state the relative amount of acids and base, HCl plus and OH minus in acidic base and neutral solution, and also give the relative pH. So for example, while I'm still trying to get this thing to print, acidic HCl plus is what compared to hydroxide? And what is the pH in relation to 7? Use your Cookie Monster mouths.
Wait, are we able to go up a bit just so I can see? I think I missed something.
Print. It is up.
Thank
Where's
you.
that? There we go.
Oh.
Woodward Hall. Main floor outside of Superlab. Okay, I'm printing to a different printer.
It's not scrolled up though.
Wait, are you able to go up a bit?
What? No, because we've already been on that for like 5 minutes.
Find the
That's-
library.
Okay, wait, plus OH.
I'll do that
and
next.
but
We have to
no.
walk upstairs for that.
Oh no.
You good?
What did you want us to do? You wanted us to find the relative.
Use your Cookie Monster mouths.
How do you know H plus go up?
Oh, which one's bigger?
Which was bigger
Um,
in an acidic solution?
oh, the acid.
The acid, the HCl plus. So you draw your Cookie Monster mouth. Because as my grade 3 teacher said, Cookie Monster wants to eat the most cookies. So it points it towards the area that has the most cookies.
Or said alligator. How does that look like a cookie monster to you?
Cookie Monster, he is underscore monster. Is the pH greater or less than 7?
Less.
Less than 7.
Wait, how do we know that?
It's more acidic.
Yeah.
Oh.
Fill in the rest of them. I am not going to go look at that printer.
Oh, what? Yeah, we should close the door on this new fellow.
And then we'll make a riddle. Oh
Yeah,
yeah.
shut the door.
No. I think go close it. Nicholas, quick.
Use keys.
And
Wait,
what
I'll
do you
search
think
up
of
a
the
riddle. I'll search
Think
up a
of
hard
the
riddle.
Yeah.
Hardest riddles
You check
ever.
that door's locked.
It is locked.
That was locked.
It's got keys, guys.
You didn't bring them with him. Wait, what did we get?
Yeah,
for
why
the
would he bring
calculator?
the key with us?
Be ready to open the door though. Like,
Yeah, it's kind of. Well,
Wait,
we can
that's
check our
the-
marks right now
Wait,
too.
I'll
get the, get
No,
the.
it's not acid.
I'm-
Yeah, and then you go up and ask it, what's the riddle?
Taylor, what was the calculation you did?
You just do, you include the molar mass of H2O.
Which is what?
So now we include it.
In the total, it should be 126 grams.
Divided by 1 mole?
Divided by 1 mole. Yeah.
Which riddle are you doing?
What's the riddle?
Oh, he's here.
Hello? What's the riddle?
Wait.
Oh, what?
You see a boat filled with people. It is not sunk. But when you look again, you don't see a single person on the boat. Why?
Yeah, hold it. You see a boat full of
Filled
people.
with people.
Yeah.
It has not sunk. But when you look again, you don't see a single person on the boat.
Because they're
Why?
all dead.
No.
No, okay, close the door.
Yeah. No, open it again.
Repeat
I
it.
do have a key.
What is the answer?
I don't know.
Ask him.
No, I'm not giving you the keys.
What's the answer?
Let him in.
Out.
What? No, they're not, because if they were alive, they'd be persons. If they're dead, they're still people, but they're not persons. That's a science phonetics answer.
No.
Yeah, no, that's it.
What is it?
Okay, when you look again,
It's not sunk. But when
it's
you look
not
again-
sunk. It was a pleasure craft, and they all went swimming. It's a scuba diving boat.
Ooh.
What?
You don't see a single person on the boat. Why?
Because it's scuba diving. They all jumped in to go diving.
Wait, did you get
What is it?
What is it?
All the other people were married. The person's single.
Oh.
Oh, that's good. Yeah. It is printing slower than molasses in January. I only had that copy. More is coming in. Okay. Did you write in all the other ones?
Yeah.
Oh, speaking of diving, have you ever seen a diver? When they have all their gear on and they have their big packs in the back, and they're sitting on the edge of the boat, they'll always go in backwards into the water. Why do they never go forwards?
Because then they fall into the boat.
Yeah, okay.
Mr. Newfeld,
Yeah?
I thought the more acidic something is, the lower it is on the pH scale.
No.
Yeah, so the pH is less than 7.
Oh.
The bigger one's 7. pH is less than that. So in basic solution, you should have less. You will never have 0. Because of the equilibrium, there will always be a little bit there. And at neutral, of course, they are equal.
Mr. Newfeld,
Yeah.
I still don't have my,
Pardon?
I still don't have my.
I know, I brought down the 5 sheets that had printed in that time. Go check again. It's printing on the printer in the hallway, and it'll be printing the rest of the first packet very slowly, and then maybe it started on the second packet by now. Miracles can happen. pH is equal to 7. For neutral. So, state the value of Kw at 25 degrees Celsius. This is just a thing you have to have memorized.
How do you do that?
Write the same stuff.
There you go. Kw equals 1.00 times 10 to the minus 14 moles per liter squared. You don't have to worry about the units, just like any other Kw. And that is equal to the concentration ratio plus the concentration of OH minus.
Can you go back? Why is it
Mole
mole
squared.
What came off?
Then you guys fix
Which
it.
order? Which was on top? That was that.
What?
That's the beginning.
You're starting with
So it came off that way. Was it face up or face down when you took it up?
For what?
But this was on top.
Oh, and we go like this.
You didn't get to
So the rest of your you're missing.
Started studying.
I think that's
What does matter for you?
You have it to 17?
Is yours
How far is this? Oh, it also goes, you got a full set? Oh, okay. Good.
You should go lab.
Okay.
How do we know that number? Like, it's,
Oh, I just told it to you.
I know, but like on a test or something.
You had to memorize it. It's 1.00 times 10 to the minus 14. It's not too bad. It technically actually might be on your data sheet. I'll check in a moment. All problems are at 25 degrees Celsius unless stated otherwise. So that way you can always use this. And we're going to put in a table that has temperature on top and, not Sorensen, and the KW. Because remember that the KQ changes with temperature. So water, when it's freezing, and we've got 10 degrees Celsius, 20 degrees Celsius, 25 degrees Celsius, because that's an important one. And then we'll just jump all the way up, so it's a really bad scale, to 60. We've got 0.114 times 10 to the minus 14. 0.295.
Will you memorize all of
10 to
these?
the minus 14? No. However, during class, if you get a problem at a different temperature, I would expect you to go to this table and look it up. That may be a hint that there's a problem like that coming.
Why don't we have this in our data booklet?
Because we're going to give you most problems at 25. And then we're going to give you other problems where we say it's a different temperature. Calculate the KW from this data.
How do you calculate the
How would you calculate it? What does KW equal?
concentration of both?
Yeah. So you would just need to know the concentration of both.
Oh, you would give us the concentration.
Yeah. So in some way you'd have to know that.
I thought you just meant like at this temperature, just figure it out.
Just figure it out.
No,
Just do it. Just do it.
If it's 100 degrees, then the water would be gas, right?
At 0, it's
If it's
no.
ultraviolet gas,
At
right?
100, it is undergoing a phase change because at 100, it is also condensing in addition to becoming a gas.
Okay, let's say it's at 200 degrees.
Yeah, then it'd be gas. Then you don't have a KW. This is in its liquid state. Also, this is technically a lie, just so you're aware. If you've ever worked in a lab, as I have, in which it really matters, it's actually 1.008 times 10 to the minus 14. So you technically should use 1.01, but in the province of British Columbia, they decided to print on your data table, I believe it's 1.00, just to make all your calculations a little easier.
Wait, Mr. Info, can you go up a tiny bit?
Yeah.
Just the page, please. Thank you. Okay, we're good.
Okay.
Thank you.
So the skill testing question is, I have H2O going to H plus OH minus, and we have a KW that has this pattern. Is the KW getting bigger or smaller as it increases in temperature?
Bigger.
Bigger. So, is this an endo or exothermic reaction? Right? Where's the energy term if the amount's getting bigger? Someone said that, but I honestly didn't hear what it was. So you said the right answer. Explain.
It's getting,
I mean,
sorry,
sorry,
hold on.
Pardon?
energy, like you can use the,
If the number's getting bigger,
React, it'll be.
which way is it
constantly-
shifting?
Right.
Shifting to the right.
So it'll be endothermic.
So it'll be endothermic. So this is an endothermic reaction. Energy plus H2O goes to H plus OH minus. So at a higher temperature, the pH is actually decreasing. Is it neutral?
No.
Why not?
Wait. When? Sorry.
As you heat it, the amount of acid, the concentrations of those are increasing. So is it still neutral?
Yeah, because both concentrations are increasing.
Both concentrations are increasing and by the same amount. So the midpoint might not be 7 anymore, because as it increases, this is no longer times 10 to the minus 14. This is very close to 13. So you can get to a temperature of water where the midpoint is 6, not 7, at a really high temperature, which is why steam to clean is an effective cleanser. In addition to the heat, it's also applying a little bit of acid and base. Not a lot, but some, especially at high temperature, it reacts much more quickly. If you cool it, water is actually getting less acidic, but also less basic. I made that table way too big. Anything else? Nope. We already answered that. Next question. Calculate the concentration of HCl plus or OH minus given the other using kW. Find the concentration of HCl plus and OH minus in a 0.100 molar HI aqueous solution with full sig figs. Just to be clear, write out the chemical equation, then the math equation, and then I want you to calculate. Should I have you do this up and around with people?
What time do we need to go to a lab?
Like 15, 20 minutes before the end of class. What do we got?
Well, because then we need to do the lab.
9:35.
Meet up after the lab and then see all of our
Yeah.
grades. So
Yeah.
shouldn't we go now?
Yeah, we got 35 minutes left.
Yeah.
I want to give you 20.
Want me to do the
We
lab,
also
a
need
little
to
bit to
run
clean,
extra time.
and then we
No,
can go
but
back.
we also need to see our
Yeah,
test results.
quick.
Let's
go
go
now.
now.
We need
50%.
You've got like a huge break coming.
Yeah, 50% extra time.
Extra time. I like. That's good. That's
Yes,
good. That's
that is
fantastic.
good.
Okay, as soon as you're done this question,
Okay.
grab a partner and do it on the board.
No, that's even the last one.
On the last page.
When I see you have the right answer, that's when you get to go out into the lab.
On the last page was the endo or exothermic.
So I need
The
Give me that one.
I,
No. Hi. Oh my god.
What I want is the concentration of H plus
There we go.
and the concentration of OH minus.
Oh no.
I'm not giving it back anymore.
As soon as you have that,
okay, so then H2O breaks down to H
Nicholas, is this your bag? Sophia, is that your bag?
plus OH minus and then H plus is
Yep.
If it doesn't give us the temperature, we like assume it's at 1.00.
Yep, always.
0.01 molar HI. Just do below. Molar HI times oh, I guess this is 1 liter. Okay, so it'll just be 0.01 moles. But, yes, add little and below. Times 1 divided by 1 equals the same number, 0.01 molar. Not mole. Moles. Okay, then we have, no, that's going to H. Then go in there and then go then go 0.01 moles times 1 over 2 equals
No, we do because
Because
the
the 25.005.
yeah.
Wait.
Copy
Are we
Moles
assuming
over
it's
OH
like
minus. And then the concentration will just be,
0.
it'll just be over 1, so
0.1.
concentration of H yeah. So do both. Compete with potential. What do we
Nope.
Is it at 25
I
degrees?
don't even know how you got the result. It's crazy stuff.
What's the temperature?
It's an equilibrium. You can't just. You know the amount of H plus? I just showed you a brand new formula, and you didn't even use it. It's like shiny and ready to go.
What's the
Brand new formula.
KW? Are we at 25 degrees?
You were at 25 degrees. 25 degrees. And you have a brand new formula. Brand spanking new.
Yeah.
Right there.
1 to the negative 14.
Erase.
Everything?
Wait, but how does the 0.01
Can I have a-
molar calculate?
Oh, I want the concentration of both H plus and OH minus. Is that a strong acid or a weak acid?
HI?
Yeah.
Strong.
So if it's strong, and what's the you should be able to calculate the strength of the H plus pretty easily. And then the other one, brand new shiny formula.
What do you mean if it's strong, we should be able to calculate it easily?
Well, in KW,
You already know it.
they know what's at.
Do you think H guy is going to provide 0.05 molar hydroxide? No, no. Brand new shiny formula.
While I was struggling, can I help one?
Is HI a strong acid or a weak acid?
I'll check.
Yeah, that would be useful. Got to check.
Ooh.
One?
Where'd my pen? Where'd the pen go?
Like this kind of?
No, I used like the water one.
Yeah, but then,
So I think I'm just gonna find this.
Check it with the strong acid.
What?
Is HI a strong acid or a weak acid? Strong, so you're using the wrong type of
I don't know.
Oh.
Which has a strong acid?
Okay.
It's not.
Okay, so, KW,
It's a strong acid.
Excellent. So what kind of arrows do you use?
KW
One way.
equals
There you go.
OH.
So
And
then,
is this
OH
equation right?
except for the arrows.
concentration
Oh,
of
okay.
H3O plus.
And if you know what kind of arrow is,
Yeah.
then for one of the calculations is super easy.
One
Zero?
to the negative.
Pardon?
Is one
So it's just
zero?
one.
Yep.
And then for KW, don't I go like concentration and that times concentration of that?
Okay, so
I do that.
KW.
Why would, is it a one-way arrow or a two-way arrow?
One way.
Okay, is that a water reaction?
14.
Yeah.
No, it's an HI reaction. KW only replies to one reaction in the world.
That was our new equation.
Yeah. So reminder,
So it's just one.
KW, people are writing KW down, which is fine, but it only applies to this reaction. If you have HI going to H plus I minus, first of all, not an equilibrium, so won't have a K, and that's the wrong K. So you have two reactions you have to worry about. Two reactions.
I think it just shows up.
It's interesting to watch everybody figure it out. You know enough to do it. Like I know you know enough to do it.
What the hell?
It's just that it involves both really easy science 10 or chemistry 11 with concentration and something we just did. You have to like mash them together in your brain.
We are not going to get our grades back today.
Yeah, you are.
We're not gonna have to.
Yeah. You have lots of.
Okay, I'm confused because there's no like.
Nice to meet you. Confused?
Aren't you just
I was
giving
confused.
us this anyway? Not stressful. The sheet?
What?
Aren't you just giving us a sheet and then we can
You have to give it back.
See, it's going to take so much time. So we should just.
We're talking about time for the lab.
I would only give you 20 minutes. We still have 5 more minutes right now.
Mr. Newfeld?
Yeah.
I can figure out the concentration.
How do you figure out H though using HI?
Yes.
Oh.
So what is the concentration ratio of flow?
No, I was like, what is that?
N squared? Like what?
What?
N.
No, you know, like
How did you figure out?
it's
Okay.
part of it is like you know the
I feel like
concentration.
I'm
Rang.
You just reading the question tells you.
But also he didn't.
If this was Chem 11, you would have no hesitation. Is that a strong acid or a weak acid?
It's a small.
So if you're sitting in Chem
I
11,
asked you
and I
first.
said there's a 0.01 molar solution, how much H plus do you have?
I asked you first, Teddy.
0.01. So the chem equation, HI goes to H plus I minus. And if this is 0.0100 molar, how much of this do you have? The same. Perfect. Now, this is set. That was set by a reaction that has no equilibrium.
But then you put it into the KW and you figure it out.
Yeah, because you have this reaction that's still occurring.
1.0 times 10 to the negative 15 equals
So just
Point
pop
zero
that
one.
number into an equation.
and solve for
Wait, but
Yeah.
you just
Can
said
we
we
just not?
Can you just not?
You just told us we couldn't use that equation.
Oh no, you can use it for this reaction. Because this
But how is
tells
that?
you what that is.
You told us that, like, when we
But how do we
did,
get-
like, balancing, it wasn't right.
So this
It wasn't right when you were trying to figure out this,
Why not?
but because there's no hydroxide in there.
No,
and-
but
and-
earlier,
and-
earlier we did that where we transferred that over to the H using, like, we just did balancing numbers, and then you said no.
I don't know what you were doing, but I don't think it's what you're describing. What I saw on the board wasn't that. Plus, you also had like this, and then you had KW next to it. That was weird. But if you just do that one way, that's Chem 11.
Yeah,
Boom,
that's
got it.
now.
Now you have a number here, you have a number there, and you can calculate the amount of hydroxide.
Did we have an answer?
Anyway, it's 9:10. Now everybody has to go to the lab. Stop what you're doing. Go, go, go. You have to tell me the number that you have to weigh out before you go out.
You know a lot of things.
What did we bring down?
Are we using your lab or not? What? 0.01 for usually one test anyway.
What's the number? What's wrong? I was looking at 1.5.
Good.
What did you calculate?
What do you mean you didn't calculate? Did you calculate anything?
You're close enough. Go.
1.575.
Yep. Excellent. Yep. Okay. Volumetric flask, are they covered by Mr. Snow? And fruits of two. 9:22, the bell will go at 9:35. If you're able to do it in one try, you should have lots of time. No, it's our telecast. But you should never be in the habit of eating. That's what happens. Why are you not wearing safe safety goggles?
Oh, no, I didn't. I just like,
Oh, then you're probably fine. But get some safety goggles on. You want to stop eating.
Now we need one more.
Your main concern is getting all of the solid into the water.
Yeah, like there's no solid in the water.
Then you
There's just like water.
You might want to do it drop by drop. No, like literally, like not the back, not the back. So try it. What do you do? The best are.
I'll go grab one.
Once you get to the end, do it drop by drop. We're getting more pipettes. Pipettes are useful when you get to the end, so you just add one drop at a time.
Oh my god, I need
Oh, well, pardon? There. You can grab that bottle, just put the top on, just put it there. Like that, distilled water bottle. Instead of, oh no, we're replenishing the pipettes.
Oh, you can. Okay, take this. Thank you. Mine's
Oh yeah.
yeah.
Did you just say here?
Yeah.
Why'd you use the same beaker? Yeah, you don't have like water and shit in it.
Yeah, so I included them. You want me to update everything?
Oh yeah.
Paraffin was coming.
Here, I'll just put a glove on there.
Wait, let's just put the paraffin on because then it's already on.
Oh yeah. Where paraffin, sir?
Oh, it's come, just, you'll be here in a second. Is that, no, and you can't get it. Yeah, you do, that was good. And did you go,
I tried to.
Excellent. Then we are going to keep these, I'm gonna go get a tray, one second. It is lovely, actually. Should we put them just on the bottom of the cart? Bottom of the cart, I'm gonna get a tray though. There's 250 millimeters in that cart. When you're done, on the tray over here, make sure it's filled with your name.
This is your vote?
Yep.
We haven't labeled it yet.
Tray right there, yep. That was perfect, I saw that one, that one was perfect. It was like, chef's kiss.
Wait, so
You're like a quarter drop off.
yeah.
Well, it depends, if you go over, you can redo it. You. No, they're very full, no. trouble in there? Using the pipette for that is going to take a long time. Use the pipette for the last few drops. Yeah, you can talk. Get it wrapped up. Rinse. Nope. Yeah, bring it to me once you're ready to go. I'll check it when you're done. Once your table's white, come see me. I'll give you your. Yep.
Just go back to, yeah.
Well, the other one. Give it back to me before you go, and you were allowed to correct the grammar. Your grammar's better than mine.
It's okay, because I got a 76
Oh, I
overall.
got 53 on the quiz. And
Okay.
59. Yo, 100% right.
1 second.
Just cover this up.
Wait, oh,
Here you go.
What? Oh my god.
Okay, so who's guessing the selection? Derek? That was
I'm
good.
really just like cover acceptance.
Okay. You know, we're talking now. Do you want me to come with you?
That's okay. As long as my English
Yeah,
work
that
went
was
up and it keeps it, because it was like.
Oh! I didn't mention at the beginning of the class. I talked with Ms. Carroll, so you should be aware. The total mark in the lab and the proficiencies have been scaled. But the mark on the individual sections, reaction kinetics, equilibrium, solubility, equilibrium, have not been. So they won't necessarily average up to the same amount of thing.
What? I don't even know what that means. That's great.
Okay. Why can't I find your name? And,
That was overall test.
oh, there it is. Apparently we'll just stick to another one.
Where do I put it when I'm done?
On the tray over there with all the other ones. On the other side, over there.
Oh.
There you go. I forgot to mention, when I did it, your mark on the test, the percentage, and it has been scaled with the other classes.
Yeah.
So it wasn't like ours was and theirs wasn't.
Yeah.
Because we looked at the whole thing. But the marks on the individual sections by
We're
by
just like
content,
raw average.
like they're just raw average.
Where do I put this?
Over there. On the other side, take a look.
Mr. Newfeld.
Wipe down your area and point to it and show it to me. Hold on, see me right after, we have it assembly and we're gonna talk. Okay,
89. Unless my studio work or my English work.
Extending height, so of course you got extending height.
it's a little low.
studied for 2 weeks.
If I look at it dead on, it's underneath the mark. I don't think so.
Oh, I got
Put
it.
it down. Put it down. Wrap the top if you want. I would never do it with a bare thumb. Where's your area? Point to it so I can see the food. Okay. And James, oh, you're near the end.
James, what is yours?
Winkle.
Oh.
Like Michael.
Like Michael.
Thank you.
I'm not.
Who's Michael?
When you're done, give me back the piece of paper.
Yeah.
It was bound to happen, but I
It is. Big dog.
Okay, if my studio work mark went up, that makes it 2. So if that was
Good.
Oh, no, it's anything. Yeah, it's good.
What do you do?
What'd you get? Emerging, developing high.
You get the senior.
And then
It's not even.
developing high emerging.
Oh, because you're second, that's why. Give me back the sheet of paper before you go. That's looking pretty good.
What's your grade?
Wrap the top,
No,
goes over a couple times. Once you give it back to me, you can go. Yep.
No, show me. You're supposed to get back to me, you know.
Take it.
Alright.
Show me.
Thank you.
Thank you.
What'd you on test?
For those of you who don't know, because I forgot to say at the beginning, before you go, the mark on the test and the proficiencies for the test were scaled with the other class, so Ms. Carroll and I talked about it. And they were done the same way for everybody. The replacement was kept using standard deviation and math things. But your test on each individual content section is just a raw percent.
Thank you.
You're about to let all the water go out. I would never do that without putting your phone on.
Well, like, is that okay that
Kind of balance on it, but yeah, it's closed. And you only need to your work for.
Oh, I did it like 20.
Yeah, you're
Solubility.
Which
Which
one's
one?
yours? Solubility.
Okay, I guess the first one.
I got 100% on that one. What'd you get on the solubility one? What's it called? 73.
Yeah,
Yeah, it's supposed to make 4 this year.
Yeah.
It's supposed to
that, did your overall mark go up? I already did all the replacements, yes, so, yeah, they did. Yeah, there you go.
Bro, I don't understand how I did so bad in this section. That's pretty hard.
Excellent. Paper, please. Give it back to me before you go. And also, the test mark overall has been scaled. Myself and Ms. Carroll looked at all of the class and did a scaling up, so your favorite. And the proficiencies have as well. However, the individual sections, reaction kinetics testing, those are just the raw percents. Because that was the easiest way to give you the information. Are you done? Are you wiped out? Thank you. You may head out. Thank you. You may head out.
Do you mean to read with you? No, it's fine. Are you okay?
That's not even my stapler. I don't know where it came from. Oh, there might be staples. Now that I think of it, because I had a stapler, and then it left. You want to put some on? I do. Yes.
Double checking.
You can go once you hand it back to me. Did you guys clean up your area? We'll need it for the next class. So tomorrow's class will be the exact same. For those who just came in, Sophia, Luca, your test mark has been scaled in conjunction with the other class. So it wasn't like individual per class. The proficiencies for the test were scaled, but the test for numbers for each section are raw. So those are the unscaled numbers, because that was the easiest way to tell you by section. Oh, absolutely, because there's a big difference, and this is all acids and bases is that.
Wait, it was scaled for us because.
No, it's scaled for all classes, AP, us, everything. When we looked at the results and we looked at it, we thought the test was a little bit too difficult, so we thought that standing high was actually 100%, so we scaled everything.
Well, it said 89. 4.
And when we had enough numbers with 4 classes to justify statistics.
So if everybody.
Oh. Oh, this is broken. This is straight up broken. Yes, it is unsafe. I cannot fix that. I'm sorry. Yes. The test mark, the overall test mark was scaled along with the proficiencies. But those are raw marks. Just so you know. Okay. This is the report card.
8 minutes last time. That's good.
Oh,
Key
it's
tour.
good.
But it's good. It's good for
It
me.
was missing.
Not for you, but it's good for me.
I know.
What? Well, I got extending on communication development.
Okay.
But I got 86.3.
There are some things to do. What
Right now.
is it? Do you have a specific mark you have to have in
I have to have
chemistry?
like overall average of like 89.5.
Thank you.
And-
You guys
But
are
right now
making.
my Cambridge is one hour.
Oh, this can ditch me.
So
Thank you.
you're only down by.
I don't even know walk.
Okay. So the chem mark was what? 83. It hits it.
No, it needs to be, I think, but if my other things went up by like if that goes to an 8, your mark goes up a little bit. I'm shocked that it didn't change my mark at all.
I think my mark went up by like 1%.
What? Maybe you can redo it. Yeah, I think my maybe. I don't really see a point though.
Maybe. Just hang on for a second. Let's get them out of here. And then let's take a look.
It's breaking open.
Yeah, all my brand new glassware.
You just want to put some things away. It's gonna go. I need to find out if my marks have changed.
Do I have yours back, Dylan?
Yeah, I gave you mine.
Okay.
Yeah. You're good.
Teachers today. Your advisor, Shecky?
Okay, thank you.
And
Yeah, did. No, I talked to him already. Okay. Sort of.
no, first of
Can
all,
you see my other marks?
I actually can. I'm not your advisor, so I'm not supposed to.
Are you recording?
So of course